as well. Okay. So I have shared my whiteboard. You would be able to see that in a bit. Okay, now we are going to talk about further differentiation. Like this is the chapter number 8. But before that, let's talk about functions. Okay. Now, when we talk about functions, when we plot functions, by looking at the plot, we can determine if the function is increasing or decreasing. For example, I am going to make a quick graph and then we'll talk about it. Okay, so let's talk about some different cases. Let's say this is the line. Okay, now I can obviously see that this function, that is y equals x, this would be the equation of this line because this line is passing through the origin. We are not sure about the gradient, but let's say the equation is y equals x. Now, by looking at the graph of this, I can certainly see that it is increasing, right?
Yeah.
If I talk about another example, let's say this one. Now, in case of this line, I can see that since this line is coming downwards, it is a decreasing function. Now, obviously, these two are lines. Let's talk about a curve in this case. Let's say I have a curve of this type. Now, what do you think about this curve? We have two parts. Okay, how do we see if a function is increasing or decreasing? Well, that's very obvious. If it is coming downwards, then it obviously means that the value of the function is decreasing. So this is f of x and this is x, and this, let's say this is 4, then this y coordinate or f of x value at this point is 3, then let's say it's 2, then it's 1, and so on. So what do we see? We see that the value is decreasing. Okay, so the value of the function is decreasing in this part. So we say that this part of the function is decreasing. And then if I talk about the other half, so what do I see? The value of the function is increasing. It was 1 here, then 2, then 3, then 4, and so on. So here it is increasing. In short, your hint is if your function is going, if the graph is going in the upwards direction, it would be increasing. And if it's coming in the downwards direction, it would be decreasing. Okay. Now, obviously, yes, this method is good for graphs which you can plot, but obviously in exam you won't be having this much time that you start plotting your graph and then you think about it, right? So we need another method to see if the function is increasing or decreasing. All right, let's talk about one last example just so you guys are able to understand the concept of what exactly we are going to do using differentiation, and then I'll talk about how to determine that. Let's say I have this type of a curve. Okay, now this is, let's say, 5, the value of function is 5 at this point, then let's say it's 4, then it's 3, it's 2, it's 1, and it's 0. Okay, now this is A, B, and C. I'll divide this graph in two parts. First part is A to B, and then the second part is B to C. Okay, take a minute, think about it, and tell me if the function is increasing or decreasing between A and B. This is the point A, this is the point B. Okay, this is the point, and we need to study A and this point. So just think about it and tell me if the function is increasing or decreasing. Yes, Munja and Nishal?
Mm, I think
That's it.
from A to B, it's increasing to the.
It's what?
I think it's increasing from A to
It's
B, and
increasing.
from A.
Very good.
Yeah.
And why is that? Because look, the value function at this point is 1. The value function at this point is 2. The value function at this point is 3. The value function is 4. So every time the value function is increasing. Just use this. Just use this for reference. If the graph is going up, it is increasing. Okay, just think about it this way. And if the graph is coming down, it is decreasing, right? We can just look at the shape of the graph and then tell. Ishal, are you there? Okay, and did you understand this? Okay, very good. Now, obviously, this method is good just to understand the concept, right? Now, in exam, if the examiner wants you to find the values of x where the graph is increasing and find the values of x where the graph is decreasing, by that I mean, let's say this coordinate is, for example, this is 2, and this is, sorry, this is minus 2, and this is plus 2. Okay. Now, what do we see? We see that the values of x for which the function is increasing are going to be which values? The values between 0 and minus 2, okay? Because they're talking about the values of x for which the function is increasing. This is the increasing part and this is the decreasing part. So for this, you'll refer to the increasing part. You look at the points and you will see that all these points have x coordinates that are between minus 2 and 0. Okay, so this is how we do it. This is just the understanding. Now I'll talk about the method and I'll talk about how to go about such questions. Okay, so I'll write down the question and then I'll explain this. Okay, find the set of values of x for which pi equals 8 minus 3x minus x square is decreasing. Okay. Now this is the question. Before talking about the question, I'll do some explanation on this part. So let's say we have a curve of this type. Okay. Now we have been discussing this. This is y and this is x. Okay. And this is the minimum point. Right. Now what do we see? As I told you, this is decreasing and this is increasing. And what exactly is happening? Why is it decreasing? If I make tangents, let's say if I make a tangent on this point and then on this point, what am I going to get? So the tangent would be of this type, then it would be of this type, and then if I make a tangent on this part, is going to be of this type, then it would be of this type. Now, what exactly I am trying to explain, okay? We know that we have colored lines We know that if any line is coming downwards, the gradient would be negative, okay? This means that the value of dy by dx would be less than 0 for decreasing part of the curve, and the value of dy by dx would be greater than 0. I repeat, what is the link between derivative and gradient? Think about them as two same things, okay? As I told you in the very beginning of this chapter when we started differentiation, the very first thing was that differentiation, derivatives, gradient, slope, everything is linked, okay? By now it should be clear that if a line is coming downwards, if we have this type of a line, it would be with negative gradient, and if we have a line of this type, it would be with positive gradient. This should be clear, okay? Now I made four tangent lines. This part is the decreasing part of the curve or of the function, and this part is the increasing part of the curve or of the function. I'm going to separate them by a line. Let's separate them by a line, okay? What do we see? Before this yellow line, the tangent lines are coming downwards. That means the gradient would be negative. That means dy by dx would be negative. And for the next part after the line, the curve is increasing because it is going in the upwards direction. If I make tangents, they are straight lines and they're going in the upwards direction. What do I know? That the gradient would be positive. If the gradient is positive, dy by dx would be positive. For now, just know I did not explain the question. I'm just trying to tell you that if your function is decreasing, dy by dx would be less than 0. And if your function is increasing, dy by dx would be greater than 0. Now let's read the question and see what exactly we are interested in finding. Okay, and just know that this curve is not for this equation. Okay, so it says find the set of values for which y equals 8 minus 3x minus x square is decreasing. So basically, we need to find the values of x for which this function or this curve is decreasing. What do we know? We know that for decreasing, the derivative is going to be less than 0. So for such questions, we need to figure this word out. If it's decreasing, we will write down the condition, and that condition is basically, since the word is decreasing, if I talk about the solution, so it would be dy by dx would be less than 0. Now I need to figure out dy by dx. So what is dy by dx if this is the curve? It is y equals 8 minus 3x minus x square. What would be the derivative? Please tell me. Yes?
It would be minus 3
Very good.
minus 2x.
Excellent. And this is less than 0. Now it's so easy. This is just an inequality. We know how to solve inequalities. This is a linear inequality, so it's even easy. Like it's comparatively, easier to solve linear inequalities. So how do we do it? We'll make x the subject. I'll take minus 3 to the other side. So it would be minus 2x less than 3, 2. And then x is, yes, what is going to happen now? I am going to take minus 2 to the other side, okay? I am going to divide minus 2 on the other side, so the inequality sign would change, and this is going to be minus 3 by 2. So this is the answer. I am going to repeat this. Please listen to me carefully if you have not understood anything. Even if you have not understood the diagram that I've made, if you did not understand the concept, that is fine. Just know, if the question is about increasing or decreasing function, it is very, very easy. Okay. If your function is increasing, dy by dx would be greater than 0. If your function is decreasing, dy by dx would be less than 0. How do we find dy by dx? We know that. Just plug in the value of dy by dx less than 0, make x the subject, and whatever range you are getting, that would be the range. Okay. Why is dy by dx less than 0? Okay. Dy by dx is less than 0 because it is decreasing. Okay, this is what I was explaining. If your function is decreasing, the lines would be coming downwards. Just look at these red tangent lines, they are coming downwards. We have studied how to plot, lines, and how to find the equation of a straight line, and there we could see that whichever line was being made this way or this way, like whatever line was coming in the downwards direction, the gradient used to be negative. If the gradient is negative, that means dy by dx would be negative, right? Just know, if your line, your curve, your function, the word could be any, they can use any term. Just know if the function, curve, line is decreasing, this is what you are going to use. And if it is increasing, dy by dx would be greater than 0. Okay. Is this okay now, Haris and Ashal? We are going to talk about another example of similar type. Okay, perfect. Let's talk about another example. So this time around it says, question number 2, it says, for the function f of x equals 4x cubed minus 15x squared minus 72x minus 8. For the function this, find f dash of x. A part says, find f dash of x. What is f dash of x? Do you guys know what is f dash of x?
The first function.
Sorry?
Is,
Mm-hmm.
the derivative
Very good.
of
dy,
fx.
very good. dy by dx is basically y dash, okay? So if you are differentiating f of x, you can write it this way, and that can be written as f dash of x. So this is the first part of the question. Please do this. Meanwhile, I'll write down the other parts. Yes, what is the answer? F dash of x, please tell me.
Of x squared minus 30x minus 72. 12x squared minus 30x minus 72.
12x squared minus,
30x
very good,
minus 72.
72. Very good. So this would be the derivative. Yes, very good. Both of you, Haris, Ashal, and yes, Munja, excellent. Okay. Find the range of values of x for which f of x is increasing. Now it's very easy for us. What is the word? The word is increasing. So for part B, since it is increasing, we can write it down this way. Either you can write down, since you do not have y here, so there's no point in writing down dy by dx would be greater than 0. Yes, that makes sense, but obviously we need to be careful with the terms we have in the question as well, okay? So if I talk about the solution, part A is done. For part B, the word is increasing. I'm writing it down this way just so you are able to remember this. So increasing means f dash of x is greater than 0. What is f dash of x? We have just figured that out. F dash of x turned out to be 12x squared minus 30x minus 72 greater than 0. Okay, now I can take, because this way it would be a bit difficult, so I can take 6 common and simplify this quadratic inequality. So 2x squared 2x squared minus 5x minus 12. Okay, this is what I am going to get. Yes. So we need two factors, two numbers, such that when we multiply them, we get minus 24, and when we add them, we get minus 5. So what do you think?
Mm. Mm.
Hmm. We get 24 when we do 2 multiplied by 12, when we do 3 multiplied by 8. So yes, would this work? Can we use this? 2x squared minus 8x plus 3x minus 12 greater than 0. This is going to work. I can take 2x common. Please pay attention. X minus 4 plus, I can take 3 common, and then again x minus 4 greater than 0. 2x plus 3, x minus 4 greater than 0. This is a quadratic inequality, and this is the fourth time or fifth time I'm telling you. In order to find the exact range of x, we need to refer to the plot of this, okay? We cannot talk about the range of x by looking at the inequality only. So think about it, make the graph, and see which values of x are going to satisfy this range. Please do it. I'll give you 2 minutes, okay? And I want an answer from each one of you. This is very, very important. And it's in front of you that we came across this the fourth time. So you can see how important it is. Okay, I got a question. So I'll explain the idea and then you guys can do it, okay? Uh, I can draw the graph with like this. Okay. Acha, okay, fine, fine. Okay, let's see how to plot the graph. So it is a quadratic inequality. So we are going to get a parabola. When we will multiply the x terms, 2x into x, that would be x squared. That means it would be a U-shaped curve. And the x-intercepts would be 2x plus 3 equals 0. So that would give me x equals minus 3 by 2. And the other one would be x equals 4. So it would be somewhere here and it would be somewhere here. I am going to make the, not the shape, something of this type, okay? This is the parabola we are going to have. It's not that good, but yes, you guys get the idea that it would be of this shape. Now, please understand this thing carefully. It's very, very important, okay? This is, what is this? Either you can say this is f of x or you can say this is y. Forget about this, that this was f dash of x, f of x. No, we are talking about quadratic inequalities as a separate case. So I'll make a line and then I'll explain it to you. Okay, this is the game. Okay, now this, let's call this y. This is y. Think about it as y equals this. So this is y and this is x. What exactly are they saying? They are saying that y is greater than 0. Okay. Y is greater than 0 means all the positive values of y. This value, this value, this value. And we are interested in finding out the values of x. Let's see the pattern of the values of x. So I'll make lines and then I'll tell you what exactly are the values of x for positive y, okay? I'm not making these lines on the exact points, but I am going to make all the lines above the y-axis because we are interested in positive x-axis. So this is the point, 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 and this is another point, this is another point, this one, this one, this one, all these points. What do you see? These are the corresponding values of x. So one side is this, that x is less than minus 3 by 2. And what do we see on the other side? That it is greater than 4 and x is greater than 4. So this is going to be your answer. Your answer is going to be of this type. You are going to write it down this way. X is less than minus 3 by 2 or x is greater than 4. I'll repeat. Whenever you come across a quadratic inequality, you cannot solve it directly like quadratic equations. You need to make the graph using the respective equation. For example, this time around we had 2x plus 3 into x minus 4 greater than 0. First, you need to think about it as an equation, make the graph, and now think about the concept. So this is y is greater than 0. So obviously when y is greater than 0, we are going to talk about the positive y-axis and the points, this point, this point, this point, all these points are basically the points along the positive y-axis, okay? And from there you are going to talk about the values of x, okay? Did you understand this? This is how we do quadratic inequalities. Yes, please ask me if you haven't understand, because This is extremely important, okay? So if you did not understand this and still you are telling me that you have understood this, that would be, honestly speaking, injustice to your own self. So please don't do that, right? So yes, I did. Okay, Shal has understood this. And what about you, Haris and Munja? Please tell me honestly.
No, I did understand, ma'am. Thank
Oh,
you.
okay, very good. And what about you, Haris? I'm waiting for your response. Understood. Okay. Now, that is good. Let's talk about the third part. I'll explain and then I'll leave it to you. I'll give you 1 minute. Do it and tell me the answers, okay? What exactly do we have in the third part? It says
Decreasing.
find the range of values of x for which f of x is decreasing. Okay, now the function is decreasing. This is the key word. So what exactly happens? Dy by dx is basically less than 0, but we need to be careful about the terms, okay? We do not have dy by dx, we have f dash of x. So we can write it down this way, that f dash of x would be less than 0. Always remember, for decreasing we will have less than sign, okay? Then I'll write down the derivative again. That would be same as we had for the last part. 30x minus 72 less than 0. The factors are going to be same again. Only this sign is different, okay? So now tell me, how are we going to solve this inequality? This is the y-axis. This is the x-axis. I am going to make the same shape again. So it would be a U-shaped curve, just like the previous one. This point would be minus 3 by 2. This point is 4. Everything is same. The only difference is, so this is y, okay? Y is less than 0. This time around, we are going to talk about the negative y-axis and all the points that are corresponding to this. So we have all these points that are below the line of x-axis. So all these points, and we are going to talk about the x coordinates of all these black points. So they are certainly going to be between minus 3 by 2 and 4. So this time around the answer is going to be what? Minus 3 by 2, x less than 4, right? X is between these two x coordinates. That is why this is the answer. So did you understand the concept? How do we solve quadratic inequalities?
Yes, ma'am.
Yes, okay. Paris, all right. Okay, very good. That's good. Now I'll give you a homework question. You can do that and then I'll check that to see if you have understood this or not. Let's talk about the next thing now. Okay. Now please pay attention. This is again very, very important. Okay. Okay. Again, I'm going to explain this first. So first, let's make a random curve and let's talk about stationary points. So I'm going to make a big curve. That is why I've made a big axis. Okay, please pay attention, all of you. So, oops. Okay, let's say this is a curve. Okay, this is just for example. Do not get scared. It's just a curve. Okay. If I talk about the stationary points of this curve, we have three stationary points: 1, 2, and 3. Why are they the stationary points? I'll tell you. Okay. Now this is a curve, okay, a big curve with three stationary points, okay, and I have told you that this curve has three stationary points. Now what exactly is a stationary point? A stationary point is either a maximum point or a minimum point. Right now, if I talk about this curve, this is the minimum point of the curve, right? And the maximum points, like we know that it's going on continuously, so we are not sure about the maximum points, but you need to understand this, that if I talk about, let's say, this curve, this and this, they are the stationary points of the green curve. If I talk about another curve, let's say this one, this is the stationary point of this blue curve. Now why are these the stationary points? Because if I make tangent lines on these points, the tangent lines are going to be horizontal. When I say horizontal, they are parallel to the x-axis. So what is the slope of any horizontal line? The slope of any horizontal line is 0. Okay. Obviously, this slope is 0, this slope is positive, this slope is negative, this slope is 0, this slope is 0. Whenever your line is horizontal, you do not have any slope there, right? So if your line is horizontal, you won't be having any slope. That means slope is 0. If the slope is 0, another thing is 0, and that other thing is dy by dx. So that would be 0. dy dy by dx is 0. Why? Because on these points, I'm talking about these particular black points, okay? On these particular black points, I am getting horizontal tangent lines. And when I say horizontal tangent lines, I mean the slope would be 0, and the slope is nothing but the derivative, okay? So always remember, if I define stationary point, I'll do it this way. Stationary point is any point on the curve that has dy by dx equals 0. This is your go-to thing, okay? So far we have discussed three things. Increasing points or increasing parts of the function are where dy by dx is greater than 0. Decreasing are where dy by dx is less than 0. Stationary point is where dy by dx is equal to 0. So we have discussed three cases. Anything that you have not understood, please tell me honestly. Understood the number. Okay, and what about you, Munya?
I understood, ma'am. Thank
Okay,
you.
very good. Then my next question is, I am going to ask this now. Okay, so I will label these three stationary points. Let's say this is P, Q, and then this one is R. Okay, what is happening to the derivative before the point Q? dy by dx, like, is it 0? Is it positive? Is it negative? What exactly is happening to the derivative before the point P? You can give me three answers, either positive, negative, or 0. Please tell me.
Negative.
Very good. It is less than 0. Excellent. Why? Because the curve is coming downwards. Okay. What is happening between P and Q? dy by dx is what? It is increasing. So it is positive, greater than 0. Very good. Because it is going in the upwards direction. Excellent, Haris. And what is happening between Q and R? Ishal, can you tell me? dy by dx is decreasing, so less than 0. Very, very good. Excellent. Okay. So now we know the three cases and we are comfortable with that. Okay. That is good. Right. Now, obviously, this was a random curve. The questions in this section could be about finding the coordinates of the maximum points or the minimum points. Always remember, in your syllabus, like in AS, they're not going to give you such examples, okay? They are going to give you such cases. Now, I will draw multiple cases. It could be something of this type. It could be something of this type, right? It could be something of this type. Okay. Now, the question could be about finding the stationary points, about finding the maximum points or the minimum points. Just know that this is a stationary point, but it is also the minimum point, right? This is and this. Both of these are stationary points, but they are also the minimum points. And do not get into this debate that this is, like if I label this, so let's say this one is, let's say 4, and then the other one is, let's say that is 5, okay? So don't get into this, okay? Always remember, whatever stationary point you have, either it is going to be positive, either it is going to be maximum point or it is going to be minimum point, okay? So this point is also a stationary point, but it is a maximum point. This point is a maximum point. So the thing is that your stationary point could be your maximum point or your minimum point. That depends on the question, and we'll figure out how to see if that is a maximum point or a minimum point, right? Okay. Now, let's talk about another case. So let's say I have a U-shaped parabola and then I have this parabola. This is a stationary point, but now we'll not talk about stationary point. We'll talk about maximum and minimum. Okay, so this is the minimum point and this is the maximum point. Let's call it A and let's call this B. Okay, so we know that these are two stationary points, but A is specifically minimum and B is specifically maximum. Now you need to understand something that is related to this concept. Okay, A is minimum because that is obvious and B is maximum because that is obvious. But other than this being obvious, we have a pattern that we can observe about the tangent lines and the derivative, and then we'll understand the concept properly. So if I talk about these tangent lines, they are coming downwards. So the derivative is negative and the derivative is positive after the line, after the point A. So dy by dx is less than 0. So I will make minus signs because the derivative is less than 0. And after the point A, the derivative is greater than 0. So I am going to make positive signs, okay? Similarly, if I talk about the point B, that is obvious, it is increasing. Now we don't need to make tangent lines. We are good enough at the concept that I can directly make these signs. I know it would be increasing. So derivative would have a positive sign. And after the point B, since it is decreasing, derivative would have a negative sign. So what is the thing that I want you to understand? If a point has negative derivative before it and positive derivative after it, that would be a minimum point, okay? If a point has positive derivative before it and negative derivative after it, that would be a maximum point. Okay, this is the only thing I want you to understand here, and this is going to happen for every maximum and minimum point. Always remember this. Okay, now if I talk about this type of a curve, in this case, again, what is happening? This is the minimum point. Negative, 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 positive, 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 negative to positive. We are going from negative to positive. That is why it is the minimum point. And if I talk about the maximum point, positive, 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 negative, 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 negative. So from positive to negative, what exactly is happening? This is the maximum point, right? This is what I want you to understand. From positive to negative, when the gradient is changing from positive to negative, you would have what? You would have a maximum point. So think about it this way: positive, max, negative, and then negative, minimum, and then positive. Okay, this is happening in case of maximum and minimum points. Any doubts about this? Please tell me. Okay, very good. All right, Munja, did you understand this?
Yes, ma'am.
Okay, and what is going to happen in another case, I'll tell you. Now I'm going to make two more graphs. Okay, now if we talk about this point, and if we talk about this point, I'm going to make tangent lines, and they are again horizontal. That means this time around it is not maximum or minimum, but it is somewhere in middle of the graph, but dy by dx is equal to 0. Okay, and again dy by dx is equal to 0, but this is not the maximum or minimum point, because if we look at the derivative before the line of dy by dx, it is positive, 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 because it is coming upwards. Again positive, 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 and in case of the other point, it is coming downwards. It is negative, 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 negative. Okay, so what do we understand? We understand that in such cases, it could be that dy by dx is 0, but still it is not the maximum or minimum point. So this is going to be the stationary point of inflection. Okay, I'll write down the term. I'll give you a summary, and then that is it for today. This is the stationary point of inflection. Okay, all right. So that is good. But obviously, like for exam point of view, I am going to give you another method for determining if the point is maximum point or minimum point. Okay, don't worry about that. Can you repeat this? Okay, all right. So Haris, so far we have discussed, and everyone, all of you, so far we have discussed three cases. Either the derivative is less than 0, so that is the case of decreasing. Either the derivative is greater than 0, that is the case of increasing, or the derivative is equal to 0. Now, when the derivative is equal to 0, we have discussed that that very point where derivative is 0 is basically a stationary point. But yes, that is a stationary point, but it could be a maximum point, a minimum point, or a point of inflection, this one. So it is a maximum point when your derivative is changing from positive to negative. So positive, maximum, negative. It is a minimum point when your derivative is changing from negative to positive. And what about this case? The derivative is 0 certainly, but it is not changing. The sign is same. It is positive before the point, it is positive after the point. It is negative before the point, it is negative after the point. In such cases where the derivative is staying same, before and after the point, such points are basically points of inflection, right? Did you understand this now? Please tell me, all of you, if this is clear or not.
Yes, ma'am, it is.
Okay, but this is just the concept. Okay, now we know we have three things. How the stationary point could be of three types: either it would be the maximum point or the minimum point or the point of inflection. We are going to relate this concept to the second derivative and then see if it is a maximum point, a minimum point, or point of inflection. Yes, Haris and Ishal, did you understand this? Yes. And what about you, Haris? Please tell me honestly. Okay, very good. Then that is it for today. I'll stop the recording.